Let's solve the part B next. We need to find the average length to the nearest meter of the vertical cables. We'll use this figure that I've drawn. I'll copy it down. Let's draw some vertical cables in yellow. Of course, they are so closely spaced, which we won't see in the figure. They are actually next to each other with, for our consideration, no space between them. This is so that the sum of their lengths can be actually represented as an integral. Because we are asked to find the average length of a vertical cable. And we can find out this average length given that we have n vertical cables as the total sum of lengths of those vertical cables divided by n. Length of a vertical cable at point x is equal to f of x, or y. However, we in this case have densely spaced cables, so that the number of cables is considered to be infinite. So in this case, we don't actually have an ordinary sum, but we have an integral. We need to set up an integral in order to find the average length. The way to set up this integral can be found intuitively, but we can also use an elegant theorem. That's an integral version of the Lagrange mean value theorem. It says that for a function f of x, which is continuous on an interval between a and b, there is some point c, which belongs to this interval, for which it holds that the value of a function at c is actually the mean value of the function, which is defined in this way. So this is mean value of f of x on the interval between a and b. Now we can use this to find the average length of a vertical cable. So L average is equal to 1 over b minus a, where those are the endpoints of the interval, and we integrate from a to b f of x dx. In our case, a is equal to minus 1 kilometer, b is equal to 1 kilometer, so 1 of b minus a is equal to 1 over 2. We integrate from minus 1 to 1, and our f of x is equal to 1 over 10 times x squared dx. So this is 1 over 60 times x to the power of 3 going from x is equal to -1 to x is equal to 1, which is equal to 1 over 60 plus 1 over 60, that is 1 over 30 in kilometers, but we need to find the average length in meters. So in this case, this average length is equal to 1000 over 30 or 100 over 3, and this is approximately equal to 33 meters.